We're really excited to share what we've been up to with Flux. So we're going to kick it off. The webinar today is going to be presented by myself and Brian Davis, the lead architect for Flux. And it's great to have all of you here. Here's an outline of what we're going to go over today. We're just going to give you a short introduction to Earthmover and our platform overall. Then we're going to talk about, what user problems motivated us to build the Flux product. Dive a little bit into the architecture of how it works under the hood. And then I'll kick it over to Brian, who's going to give you some fun live demos of how Flux can be used. And then, yeah, we'll be happy to take questions, time permitting, towards the end of the hour. So just a little bit about Earthmover. Earthmover is a public benefit corporation, and our mission is to empower people to use scientific data to solve humanity's greatest challenges. It was founded by myself and Joe 2 years ago, and our team is a mix of scientists and software engineers, and we're really in this to build that scientific cloud data platform of the future that we all know we need in order to take on all of these hard and ambitious problems facing our planet. We come out of the open source world. Joe and I met working together on Xarray, and Earthmover team is a leading maintainer and contributor to both Xarray and Czar. And we also recently launched a new open source project called IceChunk, which is a key component to our platform. IceChunk is a transactional storage engine for Czar that basically turns your multi-dimensional Czar data into a full-fledged database with ACID transactions and data version control. IceChunk also enables some really cool virtualization over existing file formats like NetCDF and HDF. And IceChunk is built in Rust, which gives it some really great performance characteristics. And so IceChunk is under the hood, and a lot of what you're going to see sort of powering the low-level I/O layer of Flux. Now, beyond our open source work, we also build this platform. We call it Earthmover platform, which is really designed to be a full-stack data management solution for teams working with multidimensional scientific data in the cloud. So this is sort of what our platform looked like a few months ago prior to launching Flux. The main ingredient in the platform is Array Lake, the object storage-based data management layer that uses IceChunk at its core. And so Array Lake provides a data catalog experience and data governance for multidimensional scientific data. And our customers were accessing Array Lake through Python, using sort of the standard familiar tools we just described, Czar, Xarray, et cetera. And with Flux, this platform is growing a whole new product, right? And Flux is a layer that sits on top of Array Lake, which translates the data that are stored in Array Lake into a bunch of different protocols that enable much broader interoperability, and flexibility. And so this is just kind of the high-level evolution of what our platform looks like. And the rest of the webinar is really a deep dive on Flux. So why did we build this layer? What motivated this? Well, what we realized over the past year is that our customers are all building what we call scientific data products. I think there's a really useful terminology for a lot of us to think about the work we do day to day. Here, I define data product just as a specialized curated data set which drives unique business or organizational value, right? So just as a few examples from our customers, Silvera, they're a carbon accounting company that verifies forest carbon credits. And in order to do that, they have built an amazing data product of global forest carbon inventory. Kettle is an insurance company, and they have an amazing data product of probabilistic wildfire risk estimates. Pelmerex is a weather data provider who has recently launched some really powerful AI-powered weather forecasts. And so, the common denominator across all these teams is they're investing a lot of time, energy, expertise, and IP into the creation of these really powerful data products, which then drive various aspects of their business. And so who's building these kind of data products? Well, these are data scientists, and data scientists love to build great data products. This is what they do, right? From prototyping, validation, evaluation. Folks are building these data products and storing them as ZAR-based data cubes in cloud object storage, because that's the format that these teams like to work with. Gives them maximum flexibility for analytics, AI, ML, and the sort of high performance types of applications that data scientists build. But simply building the data product is not enough to have an impact. These data products need to get into the hands of some users, and those users can either be internal or external to the organization. They want to consume the data in one way or another that the data product team has created, right? And so here, I've in this cartoon, I've put a sales team as sort of driving another set of requirements around the data product. Maybe the customers that they're trying to sell to, they don't want ZAR. They want data in CSV because that's what's familiar. Maybe they've realized that a great app or dashboard is necessary in order to convey the value of the data product. Or maybe there's a desire to have really detailed logging metrics around the usage of the data product in order to understand its value and its impact, right? And so these are all needs that go a little bit beyond the core expertise of data scientists and ML engineers. So here are some of the options and the workarounds we saw folks exploring. One option is to create a zoo of different derivative data sets in different formats to meet different needs. So this looks an awful lot like exporting data into a bunch of different formats like CSV, or Parquet, or TIFF, exporting static map tiles, creating a bunch of different data to serve different consumers and different use cases. So this can work, but the challenge there is now, A, you're duplicating a lot of data, and if these are large data sets, that can really run up costs. And B, it's really hard to keep all of this stuff in sync if you are then updating that data product with any kind of frequency. And so this creates a lot of complexity that can slow down the delivery of that data product. And ultimately, it seems to be falling to the data science teams to do this data engineering work. So I've tried to indicate that about having to maintain all of these pipelines. Another option we see is folks, these teams will decide to build their own custom data delivery API layer. This is some kind of backend service that is responsible for powering dashboards, providing API access, or perhaps on the fly producing different formats that the team needs to reach users. And again, we often see it's the data science team as the originators of the data product who get stuck with the job of building and maintaining this backend service. And this can start out, it's pretty straightforward to get a prototype of something like this going. But the requirements tend to balloon and grow constantly over time. There's questions around performance and scalability that emerge. There's questions around access control, security, and observability of these services. And so what starts out as a simple sounding project, if the data product grows and is successful, can actually turn into a major engineering commitment. So to kind of summarize some of the business impacts of these approaches to data delivery, we've really observed that inefficient last mile data delivery can really slow iteration time between the data product development and the end user feedback. And that has real consequences for businesses that are trying to ship high impact data products quickly. Building these sort of data delivery systems using a bespoke backend and a custom API might seem like a fast path, but ultimately it results in inflexible systems which limit innovation and scalability and interoperability. And finally, probably the most crucial consequence of this pattern is that building and maintaining this type of infrastructure for data delivery diverts data scientists from more strategic and differentiated work. So the data scientists want to be really pushing forward that AI model, or getting the best features to train the model, and not building and maintaining infrastructure. And so after seeing this pattern sort of repeated over and over in a lot of different teams, we decided to take it on ourselves to build this data delivery infrastructure layer in order to free up these teams and solve some of these problems that we were seeing. And a key part of how we decided to approach that is through the concept of standards. So at Earthmover, we're big believers in open source and open standards. And here, I'm going to walk you through the standards we have chosen to implement within Flux, which we think solve a wide range of different use cases in a really flexible, highly interoperable way. So the first one, and the one that we'll emphasize a lot, is something called environmental data retrieval. This is a standard of the Open Geospatial Consortium. So OGC API is formally defined as a family of lightweight query interfaces to access spatiotemporal data resources by requesting data at a position within an area, along a trajectory, or through a corridor. So really what this boils down to is having a large gridded data set, say a weather forecast or a big raster, and wanting to just pull out data at specific locations. That is a pattern we saw over and over. So this standard was actually originated by the UK Met Office, and it provides specifies both how you make those queries, so how you specify the points of interest, etc., and what comes back. So it defines how the data should look when they're returned in JSON, CSV, or NetCDF format. And so it's super simple. It's supported by a wide range of tools. And so that's what we chose to implement to solve a lot of these common scenarios. And Brian is going to show you some really cool demos of this. As we were implementing the EDR, we realized it would be straightforward to implement other protocols that would serve different use cases. So the two others we've implemented in this round are WMS, Web Map Service, which just allows you to get data onto a Slippy map in a super easy and highly interoperable way. And my personal favorite DAP, or OPeNDAP, the old school data access API that's supported by just about every tool and library within the environmental data space, and allows server-side subsetting of data so that you don't have to flux large volumes of data out over the internet. So I'll explain a little bit about how Flux works and how we built it. So the idea of Flux is to just make these sort of endpoints automatically available for any data that are ingested into Array Lake. So within our platform, data is organized into organizations, kind of like GitHub, and then repos or repositories. And then those repos, just like GitHub repos, have like a ref, like a branch, a tag, or a snapshot ID. And so you can address any of those within the platform through this URL structure, and any of those different services as well. So we're aiming for a really simple developer experience and developer interface. Under the hood, what's powering that is a highly scalable cloud-native architecture, right? So within our platform, all data are stored in Cloud Object Storage, which provides a single copy of the data that can then serve many different backend worker processes. And so the Flux service itself is served by a stateless auto-scaling pool of workers that can scale up and down with the load on the service. And then all of this passes through an API gateway before reaching clients. And so because of this architecture, we're able to scale the Flux service up and down really easily, elastically, in response to variable load. So here is some benchmarking we did earlier in the year, where we just ran some load testing on Flux, scaling it out from 1 to 3,000 concurrent simulated users, each making different independent requests against the service. And so what we can see here is that, the service really scales out to handle, thousands of requests per second as we add more workers to the worker pool. And so the great thing about this type of architecture is really network and S3 scalability are the only real limiting factors in this type of architecture. And that's in a pretty strong contrast to some of the legacy data serving solutions, which require sort of shared nothing architecture and data being local to the server process. We're aiming for a really excellent, smooth developer experience with Flux. Right, so this is a fully integrated, fully hosted part of the Earthmover platform, integrates with all of our identity and access controls. As an admin within the platform, you can deploy and manage these services from a CLI or with the click of a button in the web. We have logging that allows you to understand what's going on under the hood with these services, debug any requests that are having trouble. They can be configured both as public or private authenticated endpoints. And then we offer rich usage metrics in the web console that you can use to understand how the services are being used for your organization. And then finally, we have a simple pricing scheme that's just based on the volume of data scanned. So it translates directly into the amount of value that you're getting out of this service. But we also offer sort of bulk discounts for committed usage that also enable more predictable pricing for folks who are looking for something of that flavor. Now, this is the platform, but Flux is an open core service built on a very powerful piece of open source software called XPublish. So XPublish is a modern open source framework for sharing scientific data over the web, which was created by our CTO, Joe Hammond, in 2020. And from there, rapidly took off and became a popular community project. XPublish is really based around Xarray as the sort of data model, and it allows those Xarray data sets to be served through these different APIs. And it's built for scale around the Fast API framework. So the idea here is that you can self-host XPublish if you wish, or you can leverage Flux's managed service, and the use of open source and open standards give you flexibility and minimize your risk in terms of your infrastructure design. Okay, so that's the overview of Flux and how it works. And now I'm going to hand it over to Brian for a live demo. What this demo involves is really a full end-to-end workflow with Flux, starting from a completely blank slate. So Brian's going to start by ingesting some weather data, in this case, ECMWF forecast data that start as grid files. He's going to ingest that into Array Lake in ice chunk format, and then he's going to show how you can serve that exact data set out into a bunch of different applications through these different protocols. And then finally, he's going to take you on a little tour through the Flux management console. So I will stop there, and I will hand it over to you, Brian. Take it away.
Thanks, Ryan. Can everybody see my screen all right? Silence means yes. All right. Okay, as Ryan said, this is a demo in 3 acts. Act 1, I'm just going to ingest some data. Act 2, I'm going to query the data from Flux. And then Act 3, we're going to just go over the dev and admin experience briefly. So first, I'm going to rip through this first piece. So right now, I'm creating a repo, a repository for our data in Array Lake. And then I'm going to download, ingest some ECMWF IFS data. So this code up here, this is really just cleaning up some of the metadata. What's important to emphasize here is that your data just needs to be readable by Xarray. There are a couple of attributes that it needs. It needs to have some of these dimensional attributes in order for Flux to magically understand how to serve your data up across a bunch of different protocols, but that's about it. So we've written some data. We have a We have a commit, it's durable. And we can go over to the web app, we can see, oh, that just incremented. We have this new repository here. And we can see we just made this commit, and here's our data in here. So we can also double check. You know, we're now using ZAR and Xarray to reach out to ArrayLake, pulling this data in, and we're going to inspect it here. And hey, sure enough, it looks about right. Now we've grabbed one time step, one model step, so we can grab some more and we can append those as commits as well. And then we have nothing else to do. That's it. Like, we've just ingested the data, and that's it. It's if it's the metadata is right, and if it's sitting in ArrayLake, then you've done everything you need to do. So here, this thing is kind of churning away. It's making a bunch of commits. You can see it's made like 5 commits so far. And there, 7 commits, whatever. Okay, so now we can reach out and we can ping this using NC dump. So a lot of you probably use OPeNDAP. Ryan was just talking about that. I think this is still making commits, and this is there we go. Ah, there we go. Okay, so it's still making commits. Anyway, we'll do it again just so you can see that there's nothing up my sleeve. Boom, boom, boom. What we've done here, NC dump is a common tool that's used to ping OPeNDAP endpoints. So this is a drop-in replacement for netcdf files or other OPeNDAP services, and you can see it just pulls the metadata for our data set, no problemo. But that's not it. As Ryan was alluding to, a common process that we see people doing is trying to build an API on top of their data products. Here we have an API out of the box using this environmental data retrieval. And this returns coverage JSON in this case, which is an open standard like Ryan was talking about. You can see here's all of our data. Here are variables, and that includes like a lot of the metadata that we cleaned up above is now inlined really nicely. So this is actually really usable for external apps. And then, you know, of course, a picture is worth 1,000 words. So what people really want to see is they want to be able to visualize their data, right? Once we show people the ability to visualize data using WMS, people are really turned on by it. And again, I just created this repo. I just dumped this data in there. There's no caches. None of this is warm. We've just reached out and generated these tiles on the fly. But not everybody uses a notebook. So here we can go into Google Sheets here. I've prepared a little spreadsheet. There's not really much to it here, but you can see that what this is doing is this is using the EDR service to reach out and make a query, just using the URL, just as Ryan talked about, you know, that URL structure, and using the EDR API, like parameters to the URL. And you'll notice this is returning a CSV file. So it doesn't just have to be coverage JSON, or it can also return GeoJSON, and netcdf, and a bunch of different formats. And in this case, it's returning a CSV file. And this could be really useful for people who perhaps don't have programming as part of their repertoire, but they still want to be able to access your data products quickly and easily. And in fact, we have another demo here that Matt, core contributor to XPublish and about a billion other things, you know, built as just like a fun little project that's actually using the WMS service and the EDR service in order to, draw a zoomable, spinny, lovely globe, or, it's a little web app that was fairly easy to throw together. Now we've actually open sourced this, and you can see it here, and we can drop a link for you guys so that you guys can also, build something as beautiful and lovely as this without having to think it up. But again, this was just cobbling together a bunch of tools that were already out there and making use of these Flux API endpoints. And I just wanted to demo one last thing, which is using Flux in ArcGIS. So if I just drop this WMS link in here, so this is going to make use of the WMS service, which is an OGC standard, as Ryan already said. We can author layers in ArcGIS. So you can enable your geospatial analysts to poke away at your data product without having to build out an entire pipeline in order to enable them. Sorry, this is a little funky. So it has a time dimension to it, but these are all model steps. There we go. So there we go. And again, we didn't have to build out any processing pipelines or build any tile pyramids or anything. And all of this is being generated on the fly out of data that we just uploaded right now. So now I'm going to jump over. You guys kind of already saw me, go through this dashboard pretty briefly, but I want to highlight what the developer and kind of admin experience is for Flux. So we have this kind of single pane of glass where you can get a quick glance at what's going on in ArrayLake for your services and for your data. We have a data side and we have a service side. Really quickly, we can just glance and see, what's gone on over the last hour. You can see this is the demo that I just gave. And this allows you to have some insight into how people are using your service and how you can improve their experience. And as Ryan already alluded to, the cost structure for this is based off of the amount of data that's scanned, not necessarily the data that's returned in your response. And so we also try to empower you to perhaps make those queries a little bit more efficient so that they're a better experience for your users and cheaper for you and cheaper for us. And then really quickly, I'll also go over how to manage these services. So right now we're launching with 3 different kinds of service, 3 flavors, 3 protocols. So one of them is OPeNDAP version 2.0, EDR, and WMS. You can choose to make these publicly accessible, and then there's no authentication, or you can be routed through our authentication layer, which integrates with everything else in ArrayLake. And we have lots of docs with examples and all sorts of explanations on our doc site. You can just in a single click disable these services, and we also have streaming logs. So when you're trying to integrate your apps, sometimes things don't work. Perhaps a parameter, is missing, or fat-fingered an argument or something in the URL. This is great as kind of a last-ditch place to debug why these integrations are not working. We use it all the time, and our users also really appreciate it too. So that's Flux in a nutshell. Kick it back to Ryan to wrap up and go to Q&A.
All right, thanks, Brian. Love it. Let's see. Yeah, I'm just gonna wrap up kind of, our pitch for why we think you guys should use this. We've really seen folks struggle with this data delivery piece, and we've seen it slow down the progress of otherwise really ambitious and sophisticated data-driven organizations. So here's our sort of value proposition for this service. Using Flux, you can deliver data products to end users much faster. And speaking as someone who's running a startup, the ability to get to market quickly, get user feedback, and get into that iteration cycle is absolutely crucial. Leveraging standards is a real hedge against tech debt because it defines clear interfaces between different parts of your application, right? So because Flux is built on open standards, it allows you to reduce that tech debt, align with industry best practices, and immediately gain interoperability with a lot of existing tools, as Brian showed, for example, from everything from Google Sheets to ArcGIS here. Flux is designed to radically simplify the data engineering process and take really complex, expensive, and fragile data pipelines and turn them into just a completely seamless, frictionless experience. And one of the consequences of this is to ensure that data are always fresh and accurate. And within our platform, there's always a single source of truth for a particular data set or data product, and that's the latest commit within an ice chunk repo, right? And from within Flux, then that goes out to power all of these apps in a way that's totally consistent. And then fundamentally, I think the biggest sell here is just to take these AI and ML data scientists who are currently, being tasked with building infrastructure and let them get back to what they do best, which is to build great data products, do cutting edge data science, do something that's really differentiated for your organization rather than building map tiles all day, for example, right? And so we're really excited about this new development. We would love your feedback. Please reach out if you're interested in getting a more personalized demo or finding more about how Flux works. And with that, we'd love to take some questions from the audience. Jordan, please go ahead.
Hello, sir. Can you hear me?
Yes.
Okay, so I have 9 questions. I will start with the first one, and you just tell me to shut up when it's no longer my turn. So
yeah, go ahead.
The one of the biggest thing that I've struggled with is different projections in grids. Although WMS usually they default to a standard projection, although some have different projections. You understand the idea. What is the support for all the funky stuff that scientists do?
Yeah, it's a great question. And the answer today is we don't support reprojection on the fly in WMS. Your data needs to be in lat/lon 4326. I can never remember the EPSG code, but it needs to be on a regular grid. That's the status today. However, it's absolutely on the roadmap to support that on-the-fly reprojection of the data through the WMS service. So it's something we can expect to see at some point in the future, but I don't have a specific timeline for it. You had 9 questions, so I'll give you 2 more, and then we'll see if anyone else wants to jump in. Please go ahead.
Yes, sir. Second question along the same lines is dynamic chunking. So having to have one chunking schema for your whole data set, in our experience and working with working prototype for TauDB was a big blocker for us, in the sense that if you chunk for one thing, you basically ruin the performance for another thing. And yeah, I recently saw a Panjo demo of somebody with a time scroll, and they went through years. Each chunk was, I guess, a year of oceanic data, and it just sort of like flowed. But he mentioned that it needed to be chunked specifically for this. So again, I think you understand the question already. Dynamic chunking or no?
It's a deep question that probably deserves a webinar of its own. I think the specific thing you're referring to is there has been some work to visualize ZAR data directly in the browser, by essentially putting tiles directly chunked tiles into the ZAR data set that are aligned with XYZ tiles or something like that. And that's one approach, and it requires very, very specific chunking in order to work. Here we're flexible on chunking. And so the work of subsetting the data and delivering up the map tiles happens on the server side. It happens using a very high bandwidth and high performance connection to the raw data. And so what we found is that using IceChunk together with this backend is able to, get decent performance for a wide range of different queries using a single chunking scheme. All that being said, chunking remains an important parameter that's going to affect the performance of your queries, and Flux is not a silver bullet that makes that problem go away. I think the server side subsetting and processing of the data very close to where the data are stored is an improvement that does buy you some good performance and interoperability, but it can't completely overcome if you have a sort of pathological chunking scheme that's not aligned with the queries that you want to make.
Thank you very much. And I imagine because Flux is on top of Array Lake, it works a little bit differently than, like, for example, XPublish WMS. It seems that it works with like HoloViz, and essentially, as long as the Xarray data set can be loaded into memory, then it takes everything there with like the different plotting libraries, plots basically each tile individually, and it keeps going. So there's no chance of like in memory, once you load it in there, you can rechunk it sort of like dynamically and then serve it.
I'm not sure I understand the question, Jordan. Maybe we should take that one offline. But Flux is built using XPublish. So the way XPublish works is the way Flux works.
Got it. I misunderstood that one. All right. Thank you very much.
Let's see. I can see Kevin's got his hand up. Go ahead, Kevin.
Hey, great stuff. I'm curious about the OPeNDAP server. Is this kind of based on threads? Have you rolled your own? If so, is it open source? And does it also have some performance benefits and scaling benefits over a traditional threads server?
Yeah, that's a great question. So the the OPeNDAP implementation is through XPublish. Again, that's available in XPublish. And so we're providing sort of a hosted, managed version of that. And I would say it does provide some enormous performance benefits over your typical thread setup, precisely because of the architecture that is shown here. The actual server process is stateless and can be scaled out indefinitely in the cloud using only one copy of the data, right, which is the data stored in object storage. So in your typical threads setup, the data have to be mounted on a hard disk that is attached to that thread server. And that inevitably becomes a bottleneck either in how much data you can serve through threads or in how much you can scale out that service, because you're sort of bound to that single machine. And here, because the persistence layer has been completely separated from the sort of active compute layer, we have that cloud native architecture where we can scale the compute out elastically, all with one single copy of the data. And so I believe that this performance diagnostics was using OPeNDAP. And so this can power a really high availability, high throughput OPeNDAP service in the cloud.
Wow, that's great. Thanks so much.
I'll note, Kevin, that this plot, we tried to do this against a NOAA thread server for the same data. And we were rate limited at like 10 workers or something like that. So there's not really a OPeNDAP service out there that does this horizontal scaling in the same way.
Cool.
If anyone
Thank
has
you.
any ideas of one that exists in the wild, send me a link. I'd love to put them side by side.
Rich, yes.
Yeah. How do you guys scale up so like quickly to to manage these? I mean, you're not. I guess it's not like a cluster or something where you're spinning up new instances or something, or is it Lambda or something? Or I mean, how do you get that rapid scalability that'll support these web services?
Well, you got to let us have some secret sauce, Rich.
Oh, okay.
I mean,
Okay. It's fine.
But just to be clear, we see that as the work that we do and the value we offer. That's our problem if you use this service, right? Is to manage that scaling.
Yeah. No, I was just curious because I think that was one of the big problems that the EDR people ran into, right? They couldn't really figure out how to scale it. Yeah. Cool. Good job.
No, we reserve the right to change the implementation under the covers for how we do that scaling. But speaking broadly, we trigger scaling at the gateway layer based on basically the last 10 seconds worth of load. So we're looking back to see what the request volume is and how we're responding. And if we're seeing some sort of lag or we're seeing a big bump in request volume, then we start issuing scaling requests.
Yeah, very cool. Nice.
Jose.
Yeah, hello. Nice to meet you and good job, guys. Just the question is maybe aligned with the Jordan. It's a kind of reprojection was Jordan, but my own is about styles. Do you have something that is the user able to change the styles in the WMS service, or it's by default and you are providing just something that is the standard?
No, you can use any styles that are supported by Matplotlib for the raster layer. So
Okay,
I think I used Inferno, but you can throw Magma at it or Viridis or whatever you want. And yeah.
What we don't have, Jose, is symbology. Like if you have a specific, mapping of scalar values to colors or something like that, that's not supported. It's mostly designed to visualize scalar data.
okay.
I don't think we have RGB either today, but it is pretty flexible on you can determine the bounds and the color map. And we're working on figuring out how to do auto bounds globally, right? You can't just do auto limiting of the color scale on a chunk by chunk basis, on a tile by tile basis, because then you get discontinuities. And so ultimately, I think it's a metadata thing, is to set proper metadata within the data set of what you want the color bar limits to be, and then we can make that go through WMS.
Although, just to add some clarity to that, it is pretty smart. So I did actually in my demo for ArcGIS, I set auto scale to true, and because ArcGIS specifies the bounding box, the scaling happens within the bounding box, not at the tile level, and so you do get a consistent image across your entire kind of screen.
Thanks.
Okay, let's see. I don't see any other hands up. So, Mathies.
Hi, good afternoon.
Right, go
I
ahead.
had a question. We're storing some weather forecast data as ZARs on a Google Cloud bucket. Then when we need to run some computation on that, we spin up let's say a pod on a Google Kubernetes engine in Google Cloud, and that uses Python, X-ray to open ZAR, slice some data, do some computation, stuff like that. I was wondering if we were to start using Array Lake, Flux, what kind of optimizations would that give us over just, using xray.openzar as a function call, for example? Like, is there any inherent benefit there?
So there's many benefits to using the Earthmover platform over just putting your data into cloud object storage. One, we have a full data catalog that automatically is populated for all of the data sets in the platform. We are able to implement data governance on that data in terms of access controls and logging. And then there's the whole Flux layer, which this webinar was about, which enable you to run all of these services and APIs on top of your data. So if you're a team that likes to DIY everything and you have a setup that's working great for you, go ahead. And if you found a solution that works, that's fantastic. And if you're looking for a more managed service where you don't have to run and maintain all that infrastructure, then that's what we're offering in the platform. And so, there's going to be different choices that make sense for different teams, different users.
And
All right, thanks very much.
If I can jump in and add a little color there too, IceChunk is actually, what we are using internally, and we've open sourced this now in order to provide, like Ryan said, database-like transactionality and stuff. We find that that's actually a really crucial component for things like Flux when it comes to productionizing your data. If you want to make this production quality, then, for example, the ability to tag a final release of your data or a known good version of your data, and then make that tag available via Flux is really powerful. And that's something that you don't really get when you just have a pile of files, ZAR in a cloud bucket somewhere. Because when you operate on them, when you write them, when you're writing to them, you do have a period of time where you're writing to them and you have it's not transactional, right? So like you're mid-write. And if you do have these services that are serving that data mid-write, then you're going to get people with an inconsistent view of your data. And so what this allows you to do, Ryan, I think he had a slide there where he was showing the URL, and we have a ref, which is like a branch or a tag of your data. You can point these services at a particular ref, a tag, let's say, a known good tag. And then you can do all the operations you want on your data. And the people who are consuming it are not going to see it until you do a final commit and you point a new tag at it, or you update Flux to point at a different tag or something like that. And so we think that's extremely powerful. It's a very subtle thing, and it's not something that we covered that much in the presentation here, but we think that's extremely powerful for treating your data product as a product and not kind of as a science experiment, which is kind of how we've been running things up to date.
Yeah, I think that sounds super awesome. And all of this, by the way, sounds super awesome. So I'm definitely going to really dive into stuff like this. I was wondering, if you say it's the new ref, is it like a copy of the data? Like they should data storage duplicate, or is it a diff like Git?
It's a diff like Git. I highly recommend you check out there's a lot of very in-depth exploration of what IceChunk is and how it works, but it's extremely space efficient, it's extremely performant, and we're built on IceChunk. It's extremely space efficient. So it's not a full copy or anything. It's a diff, a delta of at the chunk level.
Awesome. Thanks a lot.
Scott, go ahead.
Hey, great work on all this. Solves a lot of problems that I've had over the years. I don't know if this question is adjacent to the problem you're trying to solve. I'm thinking about like modeling chain pipelines and going into and out of Fortran code. And I still think about that as having Python wrappers that are going to use these excellent Pangeo tools to get all this ZAR stuff and write out a hardnet CDF file and then run a model against that, and you get a hardnet CDF file, and then you ETL it all back up to the cloud. Is that still the way to be thinking about all of this, or are there better interfaces that I'm not aware of that might integrate with what you are doing?
That's a great question. You're going to love the manifesto that Brian has been working on this topic, which kind of addresses the more holistic workflow challenges. I'll agree with you that I think that the pattern of chaining together different stages of a workflow, but through the hard disk, writing netcdf files, is not a very scalable architecture, and it's a fragile architecture. That being said, a lot of our tooling, particularly the closer you get to the actual modeling stage, written in Fortran, it does want those files, right? And so there's a couple things we can do to help bring those applications into a more cloud native world. On the reading side, this is actually something that's enabled by OPeNDAP. Just about every netcdf library can read OPeNDAP data. So you can configure those models to load their forcing data over OPeNDAP rather than from a netcdf file sitting on disk, and you could use an URL that points to a specific ref from let's say as a tag from an IceChunk repo to achieve full reproducibility of those model runs. So that's option one. That's just on the reading side, though. We today do not have a way to write to, say, IceChunk from Fortran. However, it is coming because IceChunk is a Rust library. It's very easy to create bindings to it in other compiled languages like C. So we have a PR started on the C bindings for IceChunk. And so I believe that let's say within a year, we'll be able to stream model data directly from simulation into cloud object storage through IceChunk. And that'll allow us to chain things together through object storage and through a version controlled incremental data storage layer like IceChunk, which I think will bring a lot of benefits. I don't know if that's addressing the type of issues that you're dealing with, Scott.
Yeah, no, that's very helpful, and I'll be looking forward to that Fortran work.
Yeah, Micah, go ahead.
Okay, thanks for the webinar. I think this might be an easy question, but this is maybe more to do with the Array Lake product. But I was just wondering, so it's possible, say, like if you have your own like local S3 storage where you store your data, you can configure Array Lake to leverage that if you install, I guess, the service and give permissions. So in that case, like if I'm, and my data is sitting on a, say like not Google, Amazon, or Azure, somewhere else, it would still work with Flux and with this whole ecosystem. And are there performance impacts?
Yeah, so
with that?
If you ask about the deployment, that's a great question. Array Lake is compatible with any S3 compatible object storage service that's accessible over the internet. So we have customers using it today with on-prem, Ceph or MinIO based object storage clusters that they run. The service itself, so everything within the purple boundaries here, does run in our cloud. And so there are performance implications for doing that. So if you just want the data governance and data catalog capabilities of Array Lake, that architecture you described with the sort of hybrid approach where the object storage is on-prem is going to work fine. But if you want a high performance, data gateway that uses Flux, it's going to be really beneficial to have those two things be as close as possible to each other in terms of the network topology. And so that's where you'll suffer performance degradation if the data has to go out over the internet from your object store to the rest of the Earthmover platform. And what we don't do is just deploy our full stack on your cluster, on your servers, or in your cloud. That's not our model today.
Okay, thank you.
Okay, well, it's been great to see all of the really interesting questions and to get your feedback. Just some ways that you can follow up with us in order to stay in the loop. We just actually launched a new website for Earthmover, which I'll just take the opportunity to show off now. If you want to, let's see. All right, great. So what we'd love to have you do is scroll over to the website and join our mailing list if you want to stay in the loop on what we're up to. On this website, you'll also find our blog where you can see a big deep dive on Flux, as well as a bunch of other content. We've really been ramping up the content recently, and we've got even more cool stuff in the pipeline. So definitely subscribe to the mailing list and check out the blog. And then finally, if you're interested in learning more about Flux, you can just click on this talk to an expert button up there, and we'll give you guys a personalized demo and really help figure out if this is the product that you guys should be using. Thank you again for coming out, and stay tuned because we got a lot more stuff in the pipeline, and it was great to have the chance to share it with everyone. And thanks, Brian, for the awesome demo.